Hey guys, welcome to our YouTube channel. Today we are going to solve our Skillrack daily challenge using Python programming language. Before going to logic, if you didn't subscribe to our channel, then subscribe right now and make our work more meaningful. First, we will understand our question. The program must accept the integer n as the input and print the nth term in the given series. So this is the series. So we have 3, 5, 6, 9, 10, 12, 17, 18, 20, 24, 33 and so on. So the question is how we are getting this series. The series is formed by the numbers having exactly two ones in their binary representation. So first we are getting the integer n, then we have to print the nth term in the given series. So how you are getting the series is that the series is formed by the numbers having exactly two ones in their binary representation. So let us take our first test case. So here n is 7. So the nth term is 17. So our output will be 17. And when the integer n is 15, the 15th term in the given series is 48. So 48 will be our output. Now we will understand the logic to solve this program. So we'll have two logics. First we'll learn about the brute force approach, where we run an infinite loop from 3 to infinity and finding ones count in each number, and then if the count is equal to 2, then we are going to append the number to a list, and finally we'll print the nth term in the list. So we are solving this program based on the brute force approach. Then we are running an infinite loop from 3 to infinity and finding ones count in each number. So if count is equal to 2, then the num should be appended to a list, and finally we have to print the nth term in the list. Now in this approach the time complexity will be more, so we'll know about the other logic. So now we'll know about the other logic. So it will be done using the time complexity 0 of n. Now we have represented the numbers in the series in the binary representation. So as you can see, the first bit of each binary representation has 1 in it, right? So yes, you can see 1 in every first bit of the binary representation. So now about the second number, we can see that the 1 are replaced diagonally, right? You can see the ones in the diagonal positions. So first we'll have 10, as they have given that the numbers having exactly two ones in their binary representation. So here 0 can be replaced with 1. So when 0 is replaced with 1, we'll get 11, which is the binary representation of 3. So we cannot replace zeros further with 1. So it will be multiplied by 10. Then we'll go to 100. So here 1 can be replaced with each 0. So we'll have 101 and 110. Then after that, we cannot replace further ones. Then we multiply by 10. So it becomes 1000. So in 1000, we'll have ones in every zeros. So as you can see, they are replaced. So when further they cannot be filled with 1, we will multiply it by 10. So it becomes 10,000. And again, we'll fill the zeros by 1 diagonally. Then after, when it cannot be further replaced, we'll multiply it by 10 and so on. So we'll understand with our test case. So when the integer is 7, first we'll have 10. So the length of 10 is 2. Then for the CTR in range 1, that is for 1 to 7, the index will be minus equal to 1. Then here the index is not equal to 0, so we will decrement. Then index becomes 0. So after that, when index has become 0, we'll multiply it by 10. So 10 into 10 is 100. So the length of 100 is 2. Then when the index is decremented, as it is not equal to 0, then it becomes 1. So it becomes 1. So again it will be changed as it is not equal to 0. Then when it becomes 0, it will be multiplied with 10, becomes 1000. So the length of 1000 is 3. Then as you know, we have the seventh term is 17, that is 10001. So the index then becomes 2 and then becomes 1 as it is not equal to 0. Then after it is equal to 0, it will be multiplied by 10. So it becomes 10,000. So the index of 10,000 is 4. Sorry, the length of index 10,000 is 4. Then it will be first the zeros will be replaced by 1. So 10001 is the seventh term, that is 17. Now let us implement our program. First we'll get integer n as our input. Then we'll have the binary string as 10, as we discussed in our logic video. Then after that, we'll have the index equal to the length of binary string, and then we'll iterate over the loop using the for CTR in range 1, n plus 1. Then for each iteration, we'll have the index minus equal to 1. Then if the index is equal to 0, That is, after finding all possible replacements of 0 with 1, we'll have the binary string add up to 0, then we'll reassign the index is equal to the length of binary string minus 1. So up to n iterations, we'll know where the index should be replaced with 1. Then after that, the binary string should be used with the slice operator, and we'll have the binary string of the index plus 1. So why we have used this statement is, I'll explain it clearly. So take 10,000 and the index, for example, when it is 2, we'll replace the 0 with 1. So first we'll separate them, that is using slice operator, then again we'll concatenate them. So for this we have used this statement. Then after that, we'll print the correct decimal value, a bin string, comma 2. Now we will execute our program. We'll pass our first test case. So we have got the correct output, that is the 7th term is 17. Then we'll pass our second test case. We have got 48 as our output. Then we'll pass our third test case, that is 50. We have got the correct output.
Our program has passed all our given test cases successfully. Hope you guys understand. Thanks for watching. See you next video.